Welcome to Academic Guru's Tutoring Thursday session, where we answer all of your high school, college, and university level questions. If you would like your question to be featured on next week's Tutoring Thursdays, please submit your question to questions@academicgurusinc.com. In today's session, we will be calculating the acid dissociation constant Ka of nitrous acid using the ICE table. So let's get started. The question reads, find the Ka of nitrous acid given that a 0.02 mole solution of acid has a hydrogen ion concentration of 2.8 times 10 to the negative third moles. Okay, so this is a weak acid problem, and the first thing to do here is to write out the reaction. The next step is to write out the acid dissociation expression, Ka. The next step is to write out your ICE table. We will start by writing out the components of the initial reaction. The ICE table will allow us to clearly write out the initial concentration, the change in concentration, and the equilibrium concentration. Now we can fill in the known and unknown values. The question tells us that the initial concentration of nitrous acid is 0.02 moles. Therefore, we will insert this value in the initial concentration of our ICE table for nitrous acid. We will assume that in its initial stage, nitrous acid has not yet dissociated, therefore its ionic components we will assume to be 0. We know that as the aqueous reaction takes place, the concentration of nitrous acid is reduced by some unknown value x, while the concentration of hydrogen and nitride are increased by an equivalent amount. In order to determine the equilibrium concentration, we simply add the initial concentration to the change in concentration. Now the question tells us that hydrogen has a concentration of 2.8 times 10 to the negative third moles. Therefore, we can replace our x value with 2.8 times 10 to the negative third moles. That is, since hydrogen at its equilibrium is represented by x, and we know that x is equal to 2.8 times 10 to the negative third, every x value for every other component is also of the same value. Therefore, we will rewrite the equilibrium equation using this value. Now we can go back to our equilibrium expression. After entering the equilibrium values into the equilibrium expression, you can now calculate the Ka value, which simply equals 4.6 times 10 to the negative 4. If you found this tutorial helpful, please give us a thumbs up, subscribe, or leave us a comment. We would love to hear from you. If you would like your question to be featured on next week's Tutoring Tuesday, please submit your questions to questions@academicgurusinc.com. Until next week's Tutoring Thursday, happy studying.